Imagine flipping a switch, and brilliant light floods your room in less than a heartbeat. But where does that tiny miracle begin? Most people never think about this, but inside that tiny bulb lives technology measured in millions a meter. Think about this. One factory can build hundreds of thousands of LED bulbs every single day without slowing down. Every second, machines cut, weld, inspect, and assemble parts with astonishing precision that human hands simply cannot match. And this is where it gets truly extraordinary. The brightest part of the bulb starts as a crystal almost too small to see. That crystal survives scorching heat, powerful electricity, and years of non-stop use, while barely wasting any energy. We are about to follow every hidden step, from raw minerals buried underground to brilliant light inside your home. What happens next surprised even experienced engineers, because the journey begins thousands of kilometers away from the factory. But here's what nobody tells you. Without one remarkably rare material, this entire industry would simply stop overnight. That hidden material is gallium, and nearly 95% of the world's supply begins as a byproduct of aluminum refining. China produces most refined gallium today, while smaller amounts come from Germany, Japan, South Korea, and Ukraine. Engineers refine gallium until impurities fall below 1 part per million, because even tiny contamination weakens the final LED. Now another essential ingredient enters the story: nitrogen gas, separated from ordinary air with astonishing precision. Factories cool air below minus 196 degrees Celsius, or minus 321 Fahrenheit, before separating pure nitrogen. When purified gallium meets nitrogen later, they form gallium nitride, the remarkable semiconductor that creates brilliant visible light. Next comes sapphire, an artificial crystal that supports a microscopic LED chip during manufacturing with incredible strength. Factories grow these flawless sapphire crystals inside furnaces hotter than 2,000 degrees Celsius, or 3,632 Fahrenheit. Each polished wafer travels thousands of kilometers inside shockproof containers before reaching semiconductor factories for the next astonishing transformation. But once those precious wafers arrive, they enter the cleanest rooms on Earth, where even dust becomes a dangerous enemy. Inside the spotless cleanroom, the real magic begins as invisible atomic layers slowly transform plain sapphire into a light-producing semiconductor. The reactor heats to about 1,050 degrees Celsius, or 1,922 Fahrenheit, while gases flow with microscopic precision. Gallium and nitrogen atoms settle one layer at a time, building crystals only a few nanometers thick with astonishing accuracy. One tiny mistake here could ruin thousands of future LED chips before anyone even notices a defect. After several hours, the finished wafer cools gradually to prevent invisible cracks caused by sudden temperature changes. Now, powerful ultraviolet light transfers microscopic circuit patterns onto the wafer using advanced photolithography technology. Those intricate patterns measure far thinner than human hair, reaching dimensions smaller than 2 microns across. Next, plasma etching removes unwanted material, using ionized gas hotter than lightning, but controlled with incredible precision. Engineers monitor chamber pressure near 50 milliliter, while computers adjust every variable hundreds of times each second. But the wafer still isn't a working LED, because its brightest transformation happens in the very next stage. The finished wafer now enters a diamond Dyson machine that slices thousands of tiny LED chips with breathtaking precision. The blade spins at nearly 30,000 RPM, while flowing coolant prevents heat from damaging the microscopic circuits. Vacuum tools lift each chip without touching its delicate surface, protecting structures thinner than a strand of spider silk. Next, automated bonders attach each chip onto a metal substrate using silver-rich conductive adhesive cured in carefully controlled ovens. The adhesive hardens around 150 degrees Celsius, or 302 Fahrenheit, creating a durable thermal pathway. Hair-thin gold wires, barely 25 microns thick, connect the chip to electrical contacts using ultrasonic bonding machines. Every connection must survive thousands of heating and cooling cycles without breaking, even after years of constant operation. Now transparent silicone flows around every chip, protecting it while shaping the light into a smooth, bright beam. Injection molding machines form the plastic housing, while aluminum heat sinks weight nearby to carry away excess heat. Everything finally comes together, but one final inspection decides whether this bulb earns the right to shine. Now, every LED bulb faces its toughest challenge, because one invisible flaw can shorten its life by thousands of hours. High-speed AI vision cameras capture thousands of images every minute, searching for defects smaller than 1/10 of a millimeter. Laser sensors measure every bulb within tolerances as tight as 50 microns, thinner than a single human hair. Electrical testers instantly reject bulbs drawing too much current or producing unstable voltage under carefully controlled operating conditions. Most factories reject between 1% and 3% of production before packaging, protecting customers from hidden failures. Next comes a burn-in test, where every approved bulb glows continuously for hours to expose hidden weaknesses. Thermal chambers repeatedly cycle temperatures from -40 to 125 degrees Celsius without mercy. Vibration platforms shake package bulbs thousands of times, simulating rough shipping across oceans, highways, warehouses, and delivery trucks. Even with advanced robots, experienced technicians still spot subtle color differences that machines occasionally overlook. Every approved bulb now carries years of engineering, but its worldwide journey is only just beginning. Every year, factories produce well over 10 billion LED bulbs, enough for every person on Earth to receive another one. The global LED lighting market now generates well over $100 billion annually and continues expanding rapidly. China leads global production, followed by Japan, South Korea, India, and the United States, each supplying different strengths. Together, these countries manufacture roughly 85% of the world's LED lighting products through highly automated facilities. More than 2 million people worldwide design, manufacture, test, package, transport, and sell these remarkable sources of light. Did you know the first practical blue LED earned its inventors the 2014 Nobel Prize in Physics? Did you know LEDs consume up to 80% less electricity than traditional incandescent bulbs, while lasting dramatically longer? Did you know one efficient LED can prevent hundreds of kilograms of carbon emissions throughout its working lifetime? Researchers already developed smarter LEDs that communicate, purify air, support agriculture, and adapt automatically to human biology. But before this incredible journey ends, there's one final truth that will forever change how you see every light bulb. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. Behind every beam of light stands thousands of skilled workers, powerful machines, and decades of scientific discovery working together. Every time you switch one on, you witness millions of precise engineering decisions happening in perfect harmony. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.